Hey everybody, it's Lon Seidman. We've been talking a lot on the channel about all the different choices we're seeing in Connecticut now for internet service, and I reached out to a bunch of ISPs here in the state to see if we can get a behind-the-scenes tour. Nobody wanted to do it except Go NetSpeed, and I'm joined today by Tom Perrone,
nice to meet you.
Chief Operating Officer for this region for the company. Why don't you tell us a little bit about Go NetSpeed, what you're offering, and then we'll take a tour of all the stuff that you do here.
Sure. So 2018 we started building in Connecticut. We started building in 2016 in Pennsylvania, but time frame is pre-pandemic, but we knew that competition was needed in the market because we've had the same two providers, a cable company and a telephone company, that were not upgrading and not keeping up with the speeds that we know that the industry demands, and kind of holding us all back from being able to do all the cool things like the cameras and everything that we're chasing today, streaming. So we decided we were going to basically take this on, and it's not easy to take on those giants like that, but we did have some experience in fiber from more of a business and felt that this is something we had the expertise to do. So we're going to show you the process, and I'm going to tell you what we do is not, we don't invent this, we use the pieces and we put them together, but the real secret and why we're showing you what happens behind there is the service promise and the experience that we feel we give to customers, like every consumer from any good product would do. You can have the best suit ever, but if you don't get that customer experience of being treated with respect and answering questions, then they're probably not going to do well. So we feel super excited that we have an amazing product with amazing performance, but most of all, a group of people that really want to treat the customer right, and they're proud of the product that we have. So trucks, fiber, strand, jumpers, electronics, you're going to hear about all of it, except for the people.
So we got a couple of trucks here. A lot of them are out now because you've got a big project in the neighboring community. But I do see that you have a lot of your own infrastructure, so you're able to support this network. It's not easy to support a network as it grows, right?
Yeah, no, I mean, there's a lot to, it's not super difficult, but it's time consuming and very capital intensive, as you're going to see. The trucks are not inexpensive. Getting the fiber on the utility poles, digging it, tying it all together, supporting, thousands, hundreds of thousands of customers, and passing all these is a lot of work.
And you got a lot of fiber.
We have a lot of fiber. So
yeah.
That truck happens to be a line truck that builds the fiber between the utility poles for miles and miles and miles. There's all types of different scenarios and different trailers that, as you'll see over there, there's strand. That's the support member between the utility poles that the fiber gets lashed to or tied to. This happens to be like a 48 count fiber cable that gets overlashed to that strand, that as we go down the street, we roll this out and we deploy this during the very early stages of our build.
So this is the first step, get that up on the main pole, kind of like the main thoroughfare for the data.
And making sure that every street has connectivity back to what we're going to show you is a central office.
And you need a lot of it because there's a lot of miles here to go. And fiber's not cheap either, is it? So no. I just thought this was kind of interesting, is that you think of these big utility projects, you don't often think about, there's simple components to them.
Yep.
We've got here, I'm not going to touch the end of it because you don't never want to touch the end of fiber, but really it's just a cable with fiber optic popping out of it.
Fiber optic, kind of the size of a hair.
Strands. And each one of those little hairs, as we'll see in a few minutes, can support a lot of customers.
Yes,
so it's amazing.
absolutely.
Well, Tom, there's a lot of stuff we saw out here, but there's even more inside. So why don't we head in and show us how this all works?
Sounds great.
All right, so you brought us to a warehouse, which is not something you typically associate with an ISP, but I guess you need stuff, right?
You do. So this is a volume business. We're talking about hundreds of thousands of customers that we have to hook up. We need materials to hook them up. And as you continue to walk down, we need lots and lots of splice cases, because as we bring fiber past all these homes and we're going to set up new pops, we need these Coyote splice cases. So we need lots of those as we continue our builds. And then, of course, these are just a few of the things that go on for every build.
Right.
But behind us over here is the Nokia ONTs and the routers. We need one of those for each one of the customers that want our service.
So you got a case of those, you pull one out of the box and
pull them
hook
out
up.
every morning. The guys
Yeah.
come here, they load up their trucks. They have 5 or 7 installs, and they take 5 or 7 routers. They get scanned in, they get scanned out of the office, they get associated with the account, and then they go out throughout the day and hook those folks up. They can drive trucks right in and out of here. Same goes for the guys that are building the backbone. They get their materials for the day, check it out, and go hang it.
And Connecticut's a growing market for you. I guess New Britain, the whole city, you're in the process of wiring up right now. So
Yeah.
that's why you need a lot of this.
Yeah, absolutely. So every day, every year, we decide we're going to build a certain amount of miles in certain areas, and we decide that with our own criteria of what makes an area most successful. The cool thing about New Britain is they had the foresight to say, we want broadband fiber infrastructure everywhere because we know that that's the future that's going to attract folks to our city. So they worked with us to fill in the voids of areas that we normally would not have. So their entire city is going to be built out in 2 months. We've already done half of it.
Oh, wow. So it goes quick once you get going. But
Yeah, I mean, there's a process which we're going to see of getting on the pole, and that's not always very easy, but we've done this a couple of times, and we've gotten pretty good and hired the right folks to be able to do a lot of this in a short amount of time.
So Tom, this is kind of a simulation of a typical installation for GoNetspeed and your fiber technology. So why don't you kind of give us a tour and walk us through how this all works?
Sure. So inside the house with our service, we have a Wi-Fi 6 router, which is gigabit capable. That gets hooked electrically to the ONT. The ONT is a 10 gig ready device. That main function of this device is to take the optical and convert it to electrical.
And electrical being like Ethernet, basic.
Yes, because
home
from
internet
at this
technology.
point,
Yep.
everything's going to be transport of light and glass. So on the inside of the house, these 2 devices exist, and then that's going to transition to the outside of the house over this optical cable, which is flexible.
And typically, and I have viewers who often look at my cabling who say, don't bend those fiber cables.
Right.
This can be bent.
This has a bend radius, so you could pretty much wrap around a pencil. That's pretty much the bend radius. You don't want to kink it.
Right.
But yes, it's flexible, and it needs to be because we're running this stuff in the walls and around.
Right, you have to go around
places.
things or whatever. So there's a lot of flexibility in this. And this is really just almost a direct circuit back to something we're going to see in a minute, right?
Yeah, which is what makes the fiber service amazing is the scalability. There's not any sharing going on, so each home can communicate directly back to the equipment.
So there's not a lot in between. I mean, there's obviously a lot of things, splice points, but there's, when you think about cable, there's amplifiers, there's things in between.
Yep,
There's nothing here.
That's why they call it passive optical networking. It's PON is the technology, and there's no active electronics between the house. So this is active right here, and all the way back to our CO. There's no amplifiers. There's no powered devices. It's all splicing and glass.
So a beam of light generated from this little box goes through this cable, through all this stuff.
Could
and
easily go 30 miles.
30 miles.
Back to wherever.
From one little box in somebody's house.
Yep.
It's pretty crazy.
Yep.
So we go out the house.
Out of the house with this. Now, normally this would be a little more hidden than this,
Right.
but this is actually a training spot for our technicians
Okay.
so that new folks can do the work here,
Right.
see it that it works, test the modems, configure all that. Then it comes outside the house to where you would have siding. And clear curve again used right up to this junction, which is a test point that's sitting. So this box would be sitting outside the house
on the side
near
of the
your
house.
other facilities that are coming into the house.
And is it, so these cables are pre-terminated, it looks like, so you don't have to.
Yep, these cables are pre-terminated, and there's one splice that's needed to go from our drop cable, which is going to go outside to the utility pole, and this junction point, which is an actual test point where we can read the light levels. So the light levels, the pole number that this is going to terminate on, the drop length, and the loss, which is the light level, will all be noted on, so that the technician doesn't even have to go in the house to test any if
They just
there's
plug
any
it right
trouble.
into.
Yeah, they can
Now-
test right here.
And when you talk about splicing, we're going to see what these fibers look like in a minute. They are actually spliced together
Yeah, fusion spliced together.
end to end.
Yep.
So there's a machine that just puts them together.
There's a fusion splice machine that these guys have. There are such things called mechanical splices, but we don't use those because they're not as low loss as that. So we used fusion splices.
So we go from, we're spliced in here.
Transition point to this is the cable.
This is a more rigid cable now.
This is a more rigid cable that's going to actually suspend from the side of the house to the utility pole. So this will be run with the other utilities like the electric and things that are dropped from the utility pole to the house. That's going to terminate into a connectorized, what we call a splitter, that allows any technician to plug this in without having a splice case, that he doesn't have to be in the air or anything like that.
So all the splicing is on the ground essentially.
The splicing is on the ground, so when the customer signs up, our technician first comes out with one of these, depending on the length that he needs, where this is located on the utility pole. He's going to terminate, plugs it in, he terminates that to the house. Now the outside work is done for that customer because everything from here back toward our CO is all done in preparation, what we call our backbone build, where that's done and we don't release service to that community until that's all finished. So once we've constructed that, all they need to do is do the drop and the in-home
So a
install.
lot of splicing up front, but that pays off because hooking a customer up now is one splice on the ground and a plug-in on the pole and you're done.
And that's what we want to, we make sure that we're in a position so that when our customer signs up for that hour block on a certain day, that they're not burdened with us taking extra time to find out if this light wasn't at the appropriate. So we know that in order to just go inside the house and do these 3 devices, that's going to take us well less than an hour, and we can sit there and explain the service and then help them configure this SSID so that everything comes back before he even leaves.
And I guess to some degree too, you're kind of the new game in town. So people aren't really aware of GoNetspeed. They're kind of taking a chance, if you will. So that impression is really important.
And the feedback from the process and from the techs and the time that we take to help them make sure that they have all their devices and they understand the speeds and the rest of it is really well received. I often get people that write me saying, I have never experienced such a professional interaction and helpful folks between us and the competition. It's never been that pleasant.
So it's always good to hear that, I guess,
that's
right?
amazing.
So now we're on the pole here. We've got, on this one it looks like 8 or 12 potentially, but this one has 8.
It's normally 8. So 8 customers, 8 homes out of this box would be fed. So there'd be
Each
8
have their
of
own
these drops.
8 of those drops in the rigid cable here, and then it's all glass, right? It's a glass cable from Corning, so
Glass all the way back,
all the way back.
all different types of glass, and that is hanging on what we call strand.
Okay.
So this metal,
Big, thick metal
is
thing here.
to support all the devices. That's what you may or may not see between the utility poles, but everybody that's on those utility poles in Connecticut must have this strand to support, and it keeps devices from if during ice storms. This helps
Right, it's
not
not going to
sag and break.
Right. Now I see here, there's just one cable coming out of this 8 customer
And
splitter.
this isn't even the cable.
That's not the cable, that's just the sheet for it. Yeah.
This is the support structure, which
Okay.
is Kevlar.
Okay.
The fiber is this one blue.
It's like a strand of a hair there.
Yes.
And so you can get 8 customers on gigabit service essentially.
I can get 64 to 128 customers on one of these
Really?
single fibers, depending on how many times you split it. So that's split at 8, but you could split it 8 times before that, or you could decide you want to do 16 and 16. So there's a multitude of different flavors that operators can choose. We've chosen this one for for certain reasons. But yeah, all of the splices that feed these and aggregate going up speed, there's a tremendous amount of capacity on this one fiber.
And that's because you're doing different wavelengths of light.
Yeah, it's called XGS PON, and we're able to use the different colors of light to have all of this coexist and get these great speeds of 10 gig, and I'm sure 40 gig technology is out there and 100 gig after that. But that's why we're so excited and think that the fiber infrastructure is here to stay, because number one, there's nothing faster than light, and number two, you could always change the gear. It's not like copper, whether it's
Right.
coax or twisted pair. You're never going to be able to do the types of things that you can do with light.
And over
Because
time, as,
it's-
as equipment gets more sensitive, you can have different variations of that
I
spectrum.
mean, this same technology that was out, it was 100 mag max
Right.
when it first came out, and
Right.
there was other there was something called BPON. And this is GPON.
Right.
BPON was ATM based.
Okay.
But all of that stuff evolves. The fiber is still the exact
Right, it's still light in the
same
tube,
medium.
and it's
Yeah.
and because it's light, there's no interference. So that I think probably makes
There's
it.
no interference.
Yep.
There's none of those amps. There's no
Yep.
rebuilding the quality of it. It's pulses with lasers all the way back. So you might, as if you were to follow our strand and our fiber, this gets to be a larger cable where
Larger
you can
because
see.
there's just more of these strands
Exactly.
inside, and I
Yep.
guess you need more protection around
Yep,
a larger
they call
cable,
these
right?
buffer tubes, and in
Okay.
each buffer tubes there's a series of fibers,
Yep.
and everything's color coded. You could see red, blue, green, and so on. And then the buffer tubes are also coded. So all of this stuff ties together in each one of these splice cases, and as you get closer to, so you can see this is the primary, and there's splitters in there too. This one little box is fused, it's a fused splitter as opposed to the connectorized
Okay.
splitter. So this is where the first 8 splits are happening. The second 8 splits with that same fiber is happening down. But as you go toward the POP, you're going to see that
And the
these
POP
cases
is the point
get,
of presence where
Yes,
that's
central office.
that's
point of
where you
presence,
get sent off to
where
the internet.
all of the electronics are, and where you meet the upstream, the big providers. And you'll see these cases start to get larger and larger, and the number of splices will be in there because as you're stepping away from each home, you're addressing more and more homes, and you need larger cable counts and splicing.
All right, so let's take a look at that point of presence. All right, so this is a point of presence, one of many, I'm assuming, for customers.
Yes.
And I guess it starts at the top and works its way down. So
Yeah. I mean, you would think it'd be larger, but
Yeah.
with today's technology, you don't really need anything.
and this is
much
the only
larger.
electronics between the home and you.
Absolutely.
That's
Yep.
it.
Yep. There's nothing between this device right here communicating with the ONT that's sitting at the house.
Wow.
But when the cables come in from the utility poles, the larger counts in different directions, right? They're coming in and they hit a fiber distribution panel where they're broken out in the back. That cable that's outside turns into these jumpers that'll allow us to jumper to each one of what we call these OLT ports. So there's 16 ports on this card that would serve, let's say, 1,024 customers.
Each port.
Each port will serve at least 64 or 128, depending on how you option it. And then if you were using 64 per port, that would be 1,024 on each card. So as you can see, you can fill many cards in here.
Right, you got plenty of room.
You could also stack these chassis. So this whole rack could be filled with a chassis, and that all depends on, like, what we usually do is we'll have one POP per town, and then we'll size these chassis according to the number of homes that are
And you're
in the
renting space in each town,
Yep.
so you have
Yes.
your own facilities
Yep,
for all
and
of this.
generators and all the rest of it. And then there's some other devices here that are management. It basically allows us to communicate with this remotely, in band, out of band.
And see where things are
that.
going.
Yep. Rectifiers,
Power
battery
backups.
backup,
Yeah, you need
and then
that, yeah.
generator.
Right. So you're on a
Which
backup
actually,
generator.
the transfer case for that generator was
Yeah.
right where our home demo unit
Okay,
was.
it's over
where we were
there.
talking, you could see it said.
And so if someone has a backup generator at their house, you got generation here, because there's nothing in between.
Bingo.
You've
That's
got a
huge.
much more
Yep.
reliable. So
Yes.
it's almost like the old phone company
Yeah,
days.
even
where,
even if the even if the customer had a battery running his router
Yeah.
and his ONT,
Right.
as long as we're up on this side
Right.
and there's nothing on the fiber,
Right.
then yeah,
It's almost like the old phone company days where people said, I want to keep my regular phone because it would stay on in a storm,
Yes.
provided you can, and those ONTs don't use that much power, right?
Yeah, and what Lon is getting at with the cable, where they have amplifiers and they reconstruct the signal, those are active, so they're powered, and they're powered on the poles. So they could have a power outage between the town that you might be in,
Right.
or the circuit that
Right.
you're on, and the actual place where they have the CO. So that person would lose, even though they still have power, they would lose their service.
So you have a lot less here to power because there's less in between. Now, how do you factor in the usage of the customers? Because you have to be able to have enough bandwidth coming in here to give them what they need.
Yep. So there's 100 gig cards in here, and we could also see the utilization. So we size this box depending on how many folks we have in that region, and then we will make a calculation on how much bandwidth we need coming out of each of these, because these are also chained together for different towns to provide redundancy. And then we also have the ability to graph and watch these, and we don't ever let these clip, which is why I won't say any names of other providers, but a lot of times they'll oversubscribe it to the point where during busy hour, they do hit the max. And then that looks like, that's when you start seeing that circle of death and you're buffering. That means that some of the packets have probably dropped somewhere between the internet and your house, and that causes a retransmit.
So you must have seen a big jump in usage during the pandemic.
We did.
And you had to dial it up, or you were prepared for that, right?
We were prepared because, we are out there trying to get take. Plus, we had the luxury of these other companies have been around for 150 to 100. Matter of fact, I just looked up when cable came to Connecticut. It was 1977. So that was the last time there's been a new provider in the area of Connecticut. Plus, they're still dealing with stuff that's 100 years old. Now, we came in 2018 in Connecticut, and look at in this footprint, there's not much that's here because the technology.
And you're
is there.
serving an entire town from this.
And we also had the know that we were gonna take this by storm, and we built something that we knew was going to be able to sustain, because we all know that bandwidth is going to double and double and double as many times as it can. Matter of fact, in the last 2 years, it's gone from like 100 meg, it's the starting, to 250 to 500 to a gig.
Everybody's selling a gig.
Now people are selling 5 gig,
right?
Which I haven't even enabled 5 gig because I just don't think we're there yet. But it's all possible with this stuff. But the cool part is everything from our ordering system online is all based on volume, and we're anticipating those greater speeds. So we don't have a lot of, oh my God, we have to go raise this link because we just saturated it. We're putting in huge links
that you can
in
have
here,
a larger pipe when you need to.
We could be watching and dial up or down.
Now from here, where does the data go?
So from here, it'll usually get protected, like I said, in a ring with some other towns, and then hit to one of like 5 kind of super pops or COs that have larger routers in them. And that's where we connect with the upstream tier 1 providers like the Cogents, the Crown Castles, the Global Crossings, and that's where the egress goes out to the real internet.
Right, so that's how you get out. So
that's how you reach all the China and everybody. Like those guys connect to other guys, and it's all tiered, but the routers just find the routes based on the IP address.
And the internet is a network of networks, so that's how
a network of networks. So as soon as you get off of our last mile, you're kind of in the public internet. So what we also have that's not here, that are in those super pops, is we have the speed test servers, the GoNet speed test servers, so that you can test our speed. We can only account for you having enough bandwidth right before you get onto the actual World Wide Web where you're traversing other providers. So that device to test our network needs to be at the edge of our network. If you're trying to reach someplace in China and they only have a T1,
right, you're not
it's going to be slow, so you can't blame GoNet speed for that. So that's why you have speed test servers right at the edges of your network.
So you can assure that you're getting that.
You can assure that if you signed up for us for a gig, that you're going to get a gig. And that's another thing with our product is, not to give you the sales pitch, but if you subscribe to a gig or 500, whatever the rate is, if you don't get that all day long, you should call in a ticket, because that's the way our network is engineered. There's no rainy days.
It's not up to. It is.
You won't see.
So you're guaranteeing that if that's the speed you're paying for, at least to the edge of your network, that's the speed you're going to get.
Now, of course, there's like wireless interference. So if you're testing from your iPhone and you're way far away, you're next to a microwave, we'd ask you to plug into the router to make sure that's out. But from that router all the way back to the speed test server, you're guaranteed that much all the time.
Excellent. Well, thanks very much for giving us a tour today. It's what's amazing is how simple this really is. I mean, it's obviously.
Well, don't tell everybody because then everybody's
going to do it. Yeah,
it's expensive.
It's not easy to get on the poles and all that. The fiber is not cheap. But when you look at this, I mean, obviously this is industrial level communications gear. But I think for a lot of people watching who have their own home network, this is not much different than what you're doing at home, just at a much larger scale with a lot more engineering involved. But still,
totally agree. It's a volume, but you're right. Like the SFPs, there's a lot of similar things. This is, a switch/router. So you've seen all those things in the industry.
Right.
This is just built for thousands of people.
And if just before we close out here, if somebody is interested in getting into this business, I would imagine right now there's a hot job market for this kind of work because there's so much of it going on. What are you looking for in an employee?
The crazy part about this industry, residential, I've been in more of the commercial space for a long time with FiberTech. But in this space requires almost all levels of expertise. From you need marketing to get your word out, so you need people with marketing experience and that know social media and know digital advertising and know how to reach the towns to get your name out. All the way up through technicians, you got to have guys that know how to install this in a house, and you need the guys that splice and the linemen that go on the pole to hang this stuff all the way up back to the pipe. I mean, if you walked it through what we just said, and you need electrical kind of telecommunications engineers, network people that know
networks,
layer two transport and routing and protection methods, and even DWDM. We talked about that a little bit because this uses that. All the way through management and provisioning and guys that are behind the desk drafting how the fiber, which fibers to splice to which fibers, so they're giving the linemen that. So we are looking for everything. All the time, honestly, because we're growing. I think since 2018, I just looked up, we built past over 200,000 homes and businesses. So to do that and continue to pick up the pace, you constantly need to add resources. And that's what we're doing, because we're trying to build. It is a hot market, and now that it's disrupted, everybody's trying to get into it and get on that pole and offer this service. So we're trying to keep up with that by going as fast as I can, because like we said, they've been around for 100 years. We got a lot of catching up to do.
Got it. Well, thanks again for your time today. And if anyone has questions, leave them down in the comments section. Maybe we'll do a follow-up at some point. But really cool to kind of get the inside scoop as to how an ISP works, and you can find them over at gonetspeed.com.
This channel is brought to you by the Lon.TV supporters, including gold level supporters Brian Parker, Chris Allegretta, Hot Sauce and Video Games, Logic KGR, Tom Albrecht, and Amda Brown. If you want to help the channel, you can by contributing as little as $1 a month. Head over to lon.tv/support to learn more. And don't forget to subscribe. Visit lon.tv/s.